Hello everyone, myself Sumuko. I'm a student from SVC, currently studying in first year of engineering. Subject is principles of programming. Topic is comparison of storage classes in C language. Introduction. Storage classes in C play a critical role in determining the scope, visibility, and lifetime of variables within a program. They influence the memory allocation and management, affecting the program's efficiency and behavior. Understanding storage classes is essential for writing well-structured and optimized C programs. Let's dive into a brief overview of storage classes and their importance in C programming. Overview of storage classes. In C, storage classes define the scope and lifetime of variables and functions. There are four primary storage classes: auto, register, static, and external. Importance of storage classes in C programming. Memory management. Storage classes influence how memory is allocated and managed for variables, affecting the program's efficiency. Scope and visibility. Storage classes define the scope of variables, determining where they can be accessed and modified within a program. Lifetime of variables. The lifetime of a variable is determined by its storage class, impacting when it is created, initialized, and ultimately destroyed. Optimization. Proper use of storage classes can lead to optimized code by allowing variables to be stored in registers or by controlling their visibility. First, auto, the default storage class. The auto storage class in C is the default storage class for local variables declared within the function. The scope and lifetime. Local scope. Auto variables have local scope, meaning they are accessed only within the block or function in which they are declared. Automatic lifetime. The lifetime of auto variables is limited to the duration of the block in which they are defined. They are created when the block is entered and destroyed when the block is exited. Example, here you can see that the auto int x is equals to 10 is declared before the print value, and it is after the int main, so it's there inside the function, inside the block, and it's terminated after it exited the block. Register optimization variable access. The register storage class in C is used to suggest to the compiler that a variable be stored in the CPU register for faster access. First, faster access. Variables declared with the register keyword are intended to be stored in CPU registers and which are faster to access than the memory. Performance improvements. By minimizing memory access times, the user of register can lead to improved performance in critical sections of the code, especially in tight loops and frequent accessed variables. Compiler hint. The register keyword serves as a hint to the compiler, suggesting that the variable is heavily used and would benefit for being stored in a register. Static managing memory efficiently. A static storage class is used to declimate variables that have a durational extending throughout the entire execution of the program. Scope, lifetime initialization. Scope. The scope of a static variable can be local or global, depending on what and where it is declared. Local scope. When declared within a function or block, the static variable is located to that function or block. Global scope. When declared outside of any function, the static variable have global scope and is accessible throughout the entire program. Lifetime. The lifetime of a static variable is the entire duration of the program. It is created when the program starts and persists until the program terminates. Initialization. Static variables are initialized only once, and their values are retained between function calls. If not explicitly initialized, they are initialized to 0 by default. Example, include include function is used, and the void example function, you can see that the static int count is being declared in the block, and it is also globally in this is declared in the block, so it terminates after the block is exited. The extend link variables across file. In C, the extend keyword is used to declare a variable or function that is defined in another file or module. It informs the compiler that the specified variable or function is defined elsewhere in the program. The actual definition will be provided during the linking phase of the compilation process. Example of external variable is given here. Future trends and considerations. Compiler optimizations. Future versions of C compilers may continue to improve their optimization capabilities. This could impact how storage classes are used, with compilers becoming more adaptive at automatically optimizing variable storage and access without explicit hints from the programmer. Parallel and multi-core processing. As parallel and multi-core processing become more prevalent, there may be increased emphasis on optimizing code for concurrent execution, storage classes, and memory management. Strategies may evolve to better support parallel programming paradigms, integration with modern hardware architecture. Future C language version may introduce features or optimizations that better align with the capabilities of modern hardware architectures, including accelerations, GPUs, and specialized hardware for machine learning. Security considerations. With a growing focus on software security, future C language versions might introduce features or guidelines that mitigate common security vulnerabilities related to storage classes such as buffer overflows and data leaks. Standardization and portability. Efforts may continue to standardize C language features to enhance code portability across the platforms and compiler. This could affect how certain storage classes behave or have implemented. Memory safety and modern programming plagiarism. In the C language, might see influences for modern program plagiarisms to address memory safety issues. Future C versions may introduce features or guidelines aimed to improving memory safety without sacrificing performance. Thank you for watching.